this image shows the same thing I showed at the end of the last video. So the factors that affect cardiac output. And I said we're going to be focusing on changes to the depolarization of pacemaker cells and contractility. So those are two big ones that I will do in future videos. Right now, I'm going to more briefly talk about end diastolic volume, which is also called preload, and how it affects cardiac output through stroke volume. So I'm going to start with that right here. So this idea of preload is the name kind of makes sense. It's about preloading the heart before contraction, before that stroke volume. So we've got venous return, right? You saw that word in the previous slide, is the blood returning to the heart from the veins. The more blood that returns, the more stretch there is to the heart tissue. So, and the more stretch is going to cause more contraction. So this is venous return here. The more venous return there is, the more volume, the more quickly it returns, that's going to result in higher end diastolic volume, right? There's more volume there. The larger that volume, the more stretch there is on the cardiac muscle. So stretch of the ventricle myocardium. That's what's being shown by these arrows right here. There's so many arrows going different places, but okay. The more stretch there is, the more forcibly the heart can contract. So this is going to increase the force of contraction. That's going to increase stroke volume, right? Stronger push. This idea of increased stretch means increased contraction is maybe the part here that's not as intuitive. To think of this is kind of useful to think of it like a right, like down here, the more you pull back, the farther this person is going to shoot. So pulling back that way results in more tension generated and therefore larger force generated. Your heart muscles work the same way. This is called the Frank-Starling law of the heart. This idea that increased stretch means increased force of contraction. So the more blood that enters the ventricles, the more blood leaves. This is preload. So preload is this force of end diastolic volume. Preload and EDV are used synonymously. EDV is a volume, preload is the force due to that volume that causes the heart to contract harder. Venous return can increase with exercise, decrease with blood loss. So that's going to alter preload. Okay. The second one, and this is not directly kind of physiologically relevant when things are normal. But the other force I want to talk about here is afterload. So this is the load that the heart has to push against to get the blood out of the ventricles into these great vessels. It's directly related to aortic pressure. And aortic is the one that we're talking about the left side of the heart when we talk about this. So aortic pressure is something, right? It's usually about 80 at the low end. It's never zero. Because of that pressure in there, there's this afterload that the ventricle has to push against when it's contracting. Under normal circumstances, that doesn't vary a whole lot, right? Blood pressure is maintained. But this can be altered in cases of plaque buildup, where that would increase that, or aortic pressure and increase the demand, that afterload on the heart. The heart has to work harder to get that volume out. If it can't, it's going to alter stroke volume. So if you had increased afterload, if the heart couldn't make up for that, you'd have increased end systolic volume, right? More volume left in the heart because it can't get it out. There's too much pressure. It can't work against that pressure. This is going to result in decreased stroke volume, right? You could actually think about afterload is decreasing stroke volume, which is therefore increasing end systolic volume, right? We can't get as much blood out of the heart.